Like, for example, with the current use case, all IP traffic is allowed. Currently, we have that inbound ACL applied on this interface in here, which allows all IP traffic to flow from VLAN 33 to this DMZ subnet to VLAN 90, and from VLAN 33 to this DMZ subnet on VLAN 91. So all traffic is allowed, which means whatever IP traffic I send in this direction to Cisco ICE or in this direction to server A is going to be allowed. The question is, the big question is, will the return traffic be allowed to flow back in? If it's TCP and UDP, it is going to be allowed because ASA by default inspects TCP and UDP, and you cannot disable that inspection. It's going to be okay to return traffic. But if it's ICMP or ESP, then that's not okay. It's not going to be allowed to return traffic because the ASA does not by default inspect those protocols. So let's again confirm that let's confirm that this ACL allows IP traffic from VLAN 33 to VLAN 90 and to VLAN 91. Let's confirm that the default MPF policy is applied, and then let's confirm that I'm going to be able to send HTTP traffic to ICE, for example. Session is going to work because that's in the end TCP traffic, and the ASA statefully inspects TCP traffic. But then if I want to initiate a ping session, so ICMP packets, this is not going to work because ASA does not inspect ICMP by default. So going on on ASA 3, if we say show access list inside in, the second rule of the ACL allows traffic from subnet of the inside, allows IP traffic from the inside to the DMZ server, to the DMZ of ICE, and the second the additional entry from that ACL allows IP traffic from the inside to the DMZ where server A is located. So all IP traffic should be allowed outbound. Let's go back on PCB, and let's make sure that on either ICE or server A I can connect successfully via a TCP or UDP session. I'm going to try TCP. Let's open up a new tab to make sure HTTPS 172.16.100. There it was allowed, and if we look in the connection table, we say show localhost 10.10.32.100. We see that this host has 3 TCP flows, probably because all of them are to Cisco ICE. And if you look at the TCP flows, yes, indeed, all of them are to Cisco ICE. Let's kill those sessions anyways. But now if I try to ping 172.16.100, which is Cisco ICE, the echo packet should be allowed because it's allowed by the ACL, the echo request. But because the ASA does not statefully inspect ICMP, then echo reply is going to be dropped by the ASA. Because the ASA does not statefully inspect this, when the echo reply comes in, it's going to say, okay, this traffic flows 50 security level to 100, so it is low to high. There's no ACL allowing that traffic, I'm going to drop it. Which, what should this mean? Just to repeat this from the CCNA level, a stateful firewall, let's say, what is a stateful firewall? It means that when the ASA receives a packet inbound, it is first going to look in the connection table to see if it has an entry for that packet in the connection table. And if it has an entry for that packet in the connection table, it's going to see if the packet received matches that entry in the connection table. It matches the state of that entry from the connection table. So if it matches an entry from the connection table, it could be an allow in general of the packet or drop of the packet. It depends if the packet received, which matches that entry in the connection table, matches the state of the entry in the table. Which in a regular IP flow, if nobody tries to send some kind of spoofed packets, it is going to match successfully, and the traffic is going to be allowed. If the SA does not match with that traffic on an entry in the connection table, second is going to look, do I have an inbound or global ACL configured to allow that, which controls that traffic. So the second step the ASA is going to do, if a received packet doesn't match an entry in the connection table, it's going to then state, okay, I got that packet inbound on whatever interface. Do I have an inbound interface on that interface configured, or global ACL configured, which is a global inbound ACL, which allows that traffic? If I don't have those configured, none of inbound or global ACLs, tree is going to fall back on the security levels. It's going to say, okay, then if I don't have any ACLs configured, what does security level tell me to do? Is the traffic flowing high to low? I'm going to allow it. Is it flowing low to high? I'm going to drop it. So this is the exact order that the ASA is going to go through for any packet it receives inbound on an interface. So let's confirm that ICMP inspection. Let's confirm that if I ping now from PCB, echo request is going to work, echo request, but echo reply is going to be dropped because ICMP is not inspected by default. That's going to be dropped. Let's go on the ASA MPF default configuration and say show run policy map. We should see there is no inspect ICMP by default, and it is not. Show, if we say show service policy, inspect, and there's no option for ICMP, we just say show service policy and we say include ICMP, we should see no output, and there we go. Let's go from PCB and send a couple of ping packets to ICE. And if you go on SA and say show logging, include 172.16.100, it says in here, deny inbound ICMP from source ICE, destination PCB, type 0 code 0, which means echo reply. So as expected. Of course, to make this work, the easy option, and ideally this is what you want to do, is you go on the SA and you inspect ICMP. Because then when the echo request goes out, the SA safely inspects that, keeps track of it, it is going to expect to receive the echo reply, and then it is going to accept also the echo reply inbound. So let's go on ASA tree and initially just enable ICMP inspection. I'm going to make use of the default configuration, which of course because this policy map is applied globally, is going to affect now all ICMP traffic flowing through the ASA, inspect ICMP. Which means now that as long as traffic is allowed, as long as the echo request is allowed, then all echo requests are going to be inspected statefully and echo replies are going to be allowed back in. So now I should be able to ping from PCB both ICE, for example, and server A. Let's confirm that. Let's ping ICE, ping 172.16.3100. If we say show connection, let's say show localhost 10.10.32.100, we should also see ICMP traffic. let's say show connection protocol should be able to somehow look on the address, let's say 10.10.33.100 long. Let's ping again. Let's first of all make sure that I can ping both Cisco ICE, and there we go, I can do, and also server A 17.10.100. Now let's do some more pinging and let's look in the connection table. ICMP packets are shortly lived, and we're going to speak in a couple about the timeouts. So pretty much as soon as the echo request and echo replies are being received, the session is instantly teared down. So pretty much we don't see, it's difficult to find the ICMP entries in the state table, because as soon as the echo request goes out, echo request, and echo reply comes back in, it means that the entry from the state table is going to be teared down, because per one echo request there is one echo reply. So it's very difficult actually to catch this in the firewall state table in general. Let me try to go on PCA and say ping question mark. So let's say -n and count, and let's say minus not timestamp. I want to be able to send ICMP packets faster, so I'm going to make use of -t and -w to wait for each reply. So let's see how long it took to ping for the echo request to be for the echo reply to get back in. So TTL is round trip time is like 1 millisecond or so. So let's say that, and -t. Let's see if we have better chances now to see the entries in the state table. -t. Again, we need to be a bit lucky. We pretty much what we have to do is we have to catch the firewall when it saw the echo request but not the echo reply coming back in, which clearly it's not going to be easy. I'm not going to spend time with this. Show connection. Yeah, so it doesn't show up. You have to send packets faster than the PC sends it. That's why we don't see it. Either way. So ideally, if you want to be able to better visualize this, what you need to do is you gotta send traffic like from router, which sends ICMP packets way faster, which is gonna make the SA to keep them. You're gonna be able to see them in the state table of the SA, because otherwise we know that the SA keeps entering the state table as long as the connection is still valid, active. But as soon as the echo request goes out and echo reply comes back in, then the ASA considers that the session has to be teared down, because it makes sense. The request went out, reply came back in. There's no meaning to keep that session in the state table anymore. Anyways, that was globally configuring it. So the other option would be, let's say, show run policy map. And now let's go and remove ICMP inspection. No, inspect ICMP. One other option would be, like, for example, as we stated, maybe we want to inspect ICMP traffic only as it flows between VLAN 33 and VLAN 90. So it means that step number one, we have to match on the traffic via an ACL, match on that traffic via ACL. Then step number two, configure a class map. Configure a class map, AC map, and bind that ACL. And step number three, apply ICMP inspection. So because now I have to, initially before, when I enable ICMP inspection for all traffic, I just apply the inspection. Now I have two more steps, two more intermediate steps, because I want to enable ICMP inspection only for a specific traffic class. So let's go on ASA3 and say exit, and we say access list ICMP MPF, and we say permit ICMP traffic. You can say permit IP. Let's say permit, actually better off to say permit ICMP between 10.33.0 to 172.16.3.0. So I'm matching on ICMP, then I say class map ICMP MPF. We say match access list ICMP MPF. So now my class map configured matches on that ACL, which that ACL matches on ICMP traffic between those two subnets. And then I can still make use of the default policy map, but instead of applying the ICMP inspection on a class inspection default, I'm going to say policy map global policy, I'm going to say class, and I'm going to specify my configure class map, which matches on ICMP traffic between those two VLANs. And I'm saying for that traffic, inspect ICMP. Exit. So now if we go now on the ASA, on PCB, I should be able to ping to VLAN 90. That should be okay, because I'm inspecting ICMP traffic between VLAN 33 and VLAN 90. But I should not be able to ping from PCB to server A, because I'm not inspecting ICMP traffic between VLAN 33 and VLAN 91. If we say show service policy inspect, show service policy just, there we go. We see the ICMP inspection, and currently no packets have matched that inspection. Let's go on PCB and confirm that I cannot ping server A anymore. There we go, it doesn't work. And if we look in our traffic statistics, I see no matches in there, packet 0. It makes sense because my class map called ICMP MPF matches on this ACL, which that ACL doesn't match on traffic destined to server A, only traffic destined to ICE subnet. But of course I should be able to ping ICE. There we go, it works. And I send 4 packets, which if you look at the counters, show service policy, I should see in there, there we go, I see 8 packets because there's 4 echo requests and 4 echo replies, as expected.